So, welcome to Flipped Classroom series again, and we're going to look at lesson 8.3 today, and my name is Mr. Gill. So a couple of little cartoons for you to muse on there and think about. I'm pretty sure that everything we're doing here today is going to be useful for us later on in life. Okay? 1 plus 1, well, you can think about that. Right, let's have a look at this. So you should have this handout, and so we're looking at, this is lesson 3, and we're looking at solving this sort of equation here. Hey, look at what we've got here. We've got equations that have got brackets in them. So let's have a look at this first one here. Now, I'm going to write it down here. It's 3 times d plus 0.4 is equal to negative 3.9. Okay, let's think about this. Now, we're going to do this by looking at it in 2 different ways. We're going to use method 1. We're going to use the distributive property, which, if you remember back to chapter 7, we looked at, and then we're going to look at method 2, which, well, it's dividing first. Now, the first way we're going to do this is we're going to, what's the word that we use? We're going to expand out the brackets. So the multiplication is there. It's what we call implicit. 3 times d first of all. And then we've got 3 times 0.4. Now, I'm going to do that using mental math. 3 times 4 is 12. 3 times 0.4 will be 1.2. And that's equal to negative 3.9. Okay. So now we're down to the familiar type of equations that we looked at in lesson 3.2. And so we've got addition of 1.2. So reducing that, if we start by dealing with the addition first, we'll subtract 1.2 from this side and subtract 1.2 there. And that leaves us with, what do we have? 3d, and I think you know already 1.2 minus 1.2, that adding opposites gives us a 0. Negative 3.9 minus 1.2 takes us down to negative 5.1. And what's the last step here? The last step, 3 times d. So we're going to go through, and if we divide both sides by 3, we're going to have minus 5.1 divided by 3. And can you do that using mental math? Well, what's it going to come to there? So negative 5.1 divided by 3 is going to give us negative 1.7. So there's our answer there. D is equal to negative 1.7. So what did this method involve? Our equation had 3 and then times this, what do we call that? That's a binomial. And we expanded out. Now, if you're going to use the expanding out method, you've got to remember that little thing. Sometimes people forget. They always multiply, say in this case, the 3 times d, but then they forget about the fact that the 0.4 is also multiplied by the 3. So don't forget that little point there. Now, let's write down our equation again. So this is looking at method 2. Now, we're only going to generally use one method, but this is kind of neat. You're going to like this, negative 3.9. Now, what we've got here is, in this method, we're not going to do the expanding. Now, what we do have is we do have 2 factors. Now, what if we went through here, first of all, and we dealt with the multiplication by 3? So, in other words, what would happen if we went through and we divided by 3 first? We can do that because we have 2 factors. Divide by 3 over here. Now, what happens on the left-hand side? 3 divided by 3 gives us 1, and that leaves us with what we've got inside the binomial, d plus 0.4. Put brackets around it. I don't need to. Negative 3.9 divided by 3 gives us, what does that give us? That gives us negative 1.3. Now, because I've only got a single binomial, these 2 brackets that I put in that were originally around my binomial, they don't have to be dealt with anymore. Now, what are we going to do? What's the next thing that we're going to do here? Well, we've got a simple one-step equation. So subtracting 0.4, subtracting 0.4, and we've got d is equal to negative 1.3 minus 0.4, and that's going to be negative 1.7. And so that's exactly what we got using the first method. Now you have an option when you do these. When you're dealing with an equation which has a coefficient times a binomial, you can expand using the distributive property, or you can actually go through and divide by the coefficient first of all. All right, let's have a look at our second example here. I'm just going to erase part of the side here like this. Now look what we've got. We've got x minus 1. Effectively, that's all in brackets. It's divided by 5, isn't it? Equals 3 over 2. Now, I'm only going to use one method here. I'm not going to expand it out. It's going to be easier if we start dealing with the dividing by 5 first. So we're going to go through and dividing by 5, we can multiply by 5, can't we? And same thing on the right-hand side, we're going to multiply by 5. Now check what happens here. 5 divided by 5 gives us with 1, and guess what? We're down to our our binomial there. Because it's by itself now, we don't need to worry about the brackets. And on this side over here, this is 5 over 1, multiplying it out. 3 times 5 is 15, and 2 times 1 is 2. Okay, what's the next thing we're going to do? Well, we've got a single step to go through and finish off with now. So we'll subtraction of 1, we're going to add 1, and we're going to add 1 over here. X minus 1 is equal to, now I've got a couple of options here. We could change, well, we'll go through and we'll write this as 15 over 2 plus, and 1 could be written as 2 over 2. So, we went through, we had to add 1 there, so that's actually gives us a 0. X is equal to 17 over 2, that's an improper fraction. And going through now, we could go through and write it as a mixed number. 2 divides into 17 8 times, 1 remainder, so 8 1/2. Now, you could have done, instead of doing it that way, just if I erase that and go back to this up here, we could have done this, couldn't we? We could have done, well, 15 divided by 2, 7.5, if you wanted to do it in a decimal type way, plus 1, and that's just equal to 8.5. Now, that's perfectly permissible as well. So, I would like you to flick over the page, and let's go through, and you can pause the tape and show you know. Now, for the first one here, you can either go through and expand out the brackets, or you could simply divide everything by 2 first. All right, so pause the tape, and so I use the method of expanding out. 2 times e, and then 2 times 0.6, which is going to give us minus 1.2. Now, we're familiar with how to do these, aren't we? So what are we going to do next? We're going to add 1.2 because it was subtracted, makes it 0, and add 1.2 over there. 2e, okay, that becomes 0, of course, equals 5.4, and the last step was to divide by 2. Divide by 2. E is equal to 5.4 divided by 2 is 2.7. All right. Okay, pause the tape again and have a look at this one over here. So what I chose to do here was I chose to go through and multiply by 3. Now, if you check what we've got here, C plus 2, I put that in brackets. So there it is there in brackets. It's all divided by 3, so I went through and I multiplied both sides by 3. Now, of course, that gives me 3 over 3, so the left-hand side leaves us with just that binomial, which is C plus 2. On the right-hand side, negative 5 times 3 is negative 15, 2 times 1 when we multiply by 3. And that gives us negative 15 over 2. Now, that comes out really nicely as a decimal, so I decided I'd write that as negative 15 divided by 2 could be written as negative 7.5 or negative 7.5. The next step was to go through and we had to subtract 2 from both sides and subtract 2 over here. So we end up with C is equal to negative 7.5 minus 2, and that's equal to negative 9.5, leaving it in decimal form. Okay, let's have a look at example number 2 here. All right, Apply equations with grouping symbols. Now, let's read this question here. This is a little bit of a tricky one, but using the methods that we've developed so far, it's actually going to turn out to be pretty good. On a typical February day in Whitehorse, which is in the Yukon, the average daily temperature is negative 13.2 degrees Celsius. The low temperature is negative 18.1, and so the question here is, what is the high temperature? So, we're told what the average is. The average temperature is this number here. Now, the low temperature is the negative 18.1, and we want to find out what the high temperature is. Now, the high temperature is going to be a larger number than negative 13.2, and of course larger than negative 18.1, isn't it? Now, I want you to think here. How do you go through and find the average of two numbers? Average is easy, isn't it? So if you had number 1 and number 2 and you wanted to find the average of those two, you'd simply add them up and then divide by 2, and that's your average, isn't it? So we need to come up with an equation here. Now, I've suggested that you go through and we say, let the high temperature, in other words, the variable that we're looking for, let it equal T. Now, let's go through. So the high temperature, T, plus the lowest temperature of the day, negative 18.1, that's the sum of the two temperatures. This is the high temperature and this is the low temperature, isn't it? Now, because we're talking about the average, that's divided by 2, and that average comes out to be equal to the mean, or the average for the day, negative 13.2. So there we have it. Now that's similar to what we did before, isn't it? Now we've got a binomial on top, the t plus negative 18.1. And so we could solve this by going through division by 2. We could simply multiply by 2 there, couldn't we? And multiply by 2 on the right-hand side. So that leaves us with t. Now it's plus negative 18.1. I'm going to choose to write that as minus 18.1. And over here we've got 2 times 13.2. So 26.4, and it's negative, isn't it? So what's the next thing to do? The next thing to do to isolate the T, which is our high temperature, if we go through and add 18.1 here and add 18.1 there. And so that gives us T is equal to, those two numbers add to 0, so negative 26.4 plus 18.1, and what does that come out to be equal to? You can go through and put that in your calculator and calculate it, and that comes out to be equal to so what does that come to? Negative 8.3. All right, so that's the high temperature, isn't it? Now let's just look at that again. Let's check that, what that was. Now, the low temperature of the day was negative 18.1. The high temperature for the day we've just determined to be equal to negative 8.3. The average of those two numbers, negative 18.1 plus negative 8.3, all divided by 2 because it's an average. What does that come out to be equal to? Well, we should find that comes out to be equal to what they told us was the average temperature for the day, negative 13.2. All right. Last page there, show you no question. So I'd like you to go through and using the previous one as a model, if you go through and come up with a solution for that. So is this the equation you came up with? So similar to what we had before, the low temperature plus the high temperature, isn't it? So we're looking for the low temperature. The high temperature for the day was 1.3, and the low temperature is actually, the negative sign should be there, I beg your pardon, that's the average temperature. The average temperature is actually a negative. So That's what we've got there. So what's the best way to deal with that? Go through and division by 2. Easiest to multiply by 2, isn't it? Multiply by 2 here, leaving us with t plus 1.3, of course. 2 divided by 2 is 1, equals negative 3.0. And then we're going to go through and subtract 1.3, subtract 1.3, leaving us with t is equal to negative 3 minus 1.3 will be equal to negative 4.3. So that's our low temperature. So once again, if you check them, the low temperature, negative 4.3, plus the high temperature for the day, which was 1.3, summing those up, the average of those two numbers, you're going to add them, divide by 2, and so that comes to be equal to negative 4.3 plus 1.3, negative 3.0 divided by 2, which gives us the negative 1.5. Now, key ideas for this lesson. Okay, so when we have equations that involve, usually for us, they're going to involve a binomial, which is brackets. Okay, equations in this form like that. We have two different methods that we could use. The first method is to go through and use the distributive property. So to expand them out. And so here's an example here, 3 times x minus 3 times 4. So that's expanding it out, and we get down to a familiar equation like that. Now, the other possibility is that we can go through, and that's a typo there, if we, in this particular case, if we divide by 3, the 3's cancel out. We're left with just the binomial x minus 4. And you can take your pick, basically, about which method we use. Now, with the ones that we've been doing, on the previous page there, it is usually better. I prefer in many ways to, when we have equations like this particular one here, I prefer not to expand out, but to simply, in this case, go through and multiply by 3. So you have, next time you're in class, we're going to begin working on these examples here. Thank you.